So today is our class number 6, lecture number 6. Okay. Before we go, let us review something. Okay. As we discussed last time about something on blockchain. Okay. So can you please answer? Someone of you answer. Each block contains the hash of what? Option is the next block, the previous block, of each fork.
Of the previous
Each
block.
block contains a hash.
Yes, exactly.
The previous block.
Each block contain of previous the previous block of hash actually. Okay. Uh, only dash of data can be made on or to the blockchain.
Only addition of data can be made.
Only addition. We cannot change. We cannot delete. Yes.
Yes. Yes.
The blockchain provides a snapshot of the current states. This is true or false?
True.
True.
Are you sure?
All
I think
transactions.
it's false.
False.
Exactly. This is false. Why it is false? Because it's not keeping every nodes have all the records, not only snapshot.
Yes, all the transactions.
All the transaction from A to
Yeah,
B, it will record all the transaction. There is, there are so many transaction over there, so it records all the record, all the transaction. There is no any snapshot. When looking at public versus private, okay, please understand public versus private blockchain. It is important to look at who can dash data on the blockchain actually, right?
Right.
Added, define. Yes.
Right.
Yes, this is the answer. Who can write the data? If we are
Yes.
talking about public versus who can write.
Yes.
When look at open versus closed blockchain, it is important to look at who can read data from the blockchain. Okay. When considering a permission versus permissionless blockchain, it is important to ask, are all participants are dash equal, trusted, like, or truthful?
Trusted. I think it's equal.
Yes, it's equal actually.
Equal.
Any blockchain solution must be either public or private. True or false?
False.
Yeah, it can be any. It can be public or it can be private actually.
Yes. Public or private.
Public or private.
Yes.
It may be public or it may be private. So it is.
Yes. Must be either. It says either, not or.
Not yes. Either public or private. So we cannot say this is public or private. We can say it is the blockchain type will be the public or private.
Okay.
So it must be public or it must be private actually. Okay, so today we are going to start our new chapter. As I promised, we will do more adopt more practical approach. So we will continue with this this new lecture. So first we will learn how blocks are created. Okay. Last time we learned what is the blocks and everything. So how we are going to do the blockchain, this one. First we need to learn what is hashes. Okay, so we will learn hashes through the help of this video, and we will learn some practical example as well. Let me tell you what is hash actually. Actually, hash is a function that converts our input, or for example, they are letter, they are number or something, into encrypted output of a fixed length. Okay, A hash is created using a algorithm, and it's essential to blockchain management in cryptocurrency. For example, if we are, we wanted to create, modify some of our words, some of number, and we wanted to make as a cryptocurrency, a cryptography. So we will, taking help of hash. Okay, so let us review one of our video, like one. Okay. Let us Can you see my screen?
Yes, of course.
Yes.
No, means you can see my this
Link, yes.
this is the presentation right now, right?
Yes, the presentation, yes.
Okay, hold on, let me share you my screen, this one.
Steve and Dave use eToro to invest in the financial markets. Steve does research on, in simple terms.
We are not looking.
You cannot see? Hold on.
No, we are just listening, but not seeing.
Now?
Now, yes, yes,
Okay,
yes.
very good.
Yes.
Hashing is taking an input of any length and returning an output of fixed length. In the context of cryptocurrencies like Bitcoin, transactions are taken as an input and run through a hashing algorithm that returns an output of a fixed length. Let's see how the hashing process works. For this exercise, we're going to use the secure hashing algorithm 256, or SHA-256. In the case of SHA-256, no matter how big or small your input is, the output will always have a fixed 256 bits length. This is critical when dealing with a huge amount of data and transactions. Instead of remembering a large amount of input data, you can remember the hash to keep track. A cryptographic hash function is a special class of hash function that makes it ideal for cryptography. There are 6 properties that a cryptographic hash function needs to have in order to be considered secure. Let's go through them one by one. Property 1, deterministic. This means that no matter how many times you input the same data, you will always get the same result. This is critical because if you get different hashes every time, it's impossible to keep track of the input. Property 2, quick computation. The hash function should be able to return the hash of an input quickly. If the process is too fast, then the system won't be efficient. Property 3,
Brother, I think it is too fast. We are not hearing it very well.
based on the output hash. Notice the use of the word infeasible instead of impossible. For example, suppose you're rolling a die. Instead of getting a specific number between 1 and 6 when you roll, you instead get a hash value that corresponds to a specific number between 1 and 6. How will you be able to determine what the original number was? All you have to do is find out the hashes of every number from 1 to 6 and compare it with your result. Since hash functions are deterministic, the hash of a particular input will always be the same. This means you can simply compare the hashes and find out the original input. This is a trivial exercise when dealing with 6 possible inputs, but when working with even slightly larger data sets, the difficulty of guessing a hash increases exponentially. The only way to find the input from an output hash is through brute force, that is, by making pure, random guesses. So what happens if you use this method? If you spend every second of every day guessing hashes without sleeping, you would be guessing hashes for the rest of your life, and you would never even come close. Neither would your children if they did the same, or their children, or their children. So while it is possible to break pre-image resistance by brute force method, it takes so long that it doesn't even matter. Property 4, a small change in the input changes the whole output. Even the smallest change in input must have huge ramifications on the output. This is a critical function that aids in making the function pre-image resistant. Property 5, collision resistance. Collision resistance means that each input will have its own unique hash. Having 2 different inputs that result in the same hash is known as a collision. No hash function is completely collision-free, but much like the timeline of the brute force attack we described before, it takes so long that it doesn't matter. Property 6, puzzle-friendly. This is a pretty complex property, and it's represented in some form by this complicated-looking equation here. But math is hard, so let's turn this into words and pictures. K represents a particular value chosen. In order to fit this property, the value has to be chosen from a significantly large distribution of points. To choose a number between 1 and 5, for example, would not be sufficient. Choosing a number between 1 and 1 septillion would be significant enough distribution for a cryptographic hash. This line here denotes concatenation. Concatenation means adding two strings together. If I were to concatenate blue and sky, then the result would be blue sky. So looking at the equation again, given a hash output of y and a randomly chosen point k, it must be infeasible to find an x value such that the combining of k and x will give hash output y. Ooh, math. So what does all this stuff mean in blockchain? Why does any of it matter? The blockchain is a sequence of blocks that contain data and a hash pointer that points to a previous block, hence the chain in blockchain. A hash pointer contains the hash of all the data inside the previous block. This small tweak is part of what makes blockchain so revolutionary. Imagine a hacker attacks block 3 and tries to change the data. Because of the properties of hash functions, even a slight change in data changes the hash drastically. This means that any change made in block 3 will change the hash stored in block 2. This in turn will change the data and the hash of block 2, which results in changes in block 1, and so on. This is exactly how blockchains attain immutability. Any tiny changes in the data are immediately noticed and nullified by each preceding block. Essentially, the concept of hashing is a core part of what makes blockchains revolutionary and unique. Understanding how it works, as well as the security and efficiency it provides, is a key step towards understanding blockchain technology as a whole.
Okay, let me explain you this thing through our some practical work. Okay, can you see my screen? Hello, guys. Hold on.
Yes.
Okay. See, hash, as I explained in video, is a cryptography function. It will convert your data in cryptography function hash, so no one can understand what you are going to write. For example, I am writing some data like this is.
Ayo, așa se fac. Ayo e cactu.
Sorry. Can I continue?
Yes, yes, sorry.
Okay. So, for example, I'm writing here, this is Noman. Okay. I write my name, so system automatically convert this message to some hash. Okay. For example, if I write this thing, again and again, so system will keep giving me same result in terms of this hashes. Okay. So right now, this is the hash is P4B, D4B, and some message is 40 character message. It will automatically convert and through cryptography function, and it give me an some hashes against my data. For example, if I write Albania leasing, see, Albania leasing is this is converting into hash. This data is converted with the hash function. For example, even if I will change one dot, it will convert complete hash function. If I remove hash, it will give me revert back to be the same function again, like that. Okay, brother?
Okay.
So this is you understand? Everyone understand about the hash function?
Yes, brother.
Okay, very good, very good. Let's go back to our next slide. Now we understand what is hash. Now I am going to explain you what is the block. Okay. See.
Can I ask you a question, please?
Yes, sure.
I saw the hash down. It was the same length.
Yes.
So whatever it is written,
lengthwise will remain same.
I see. So if we write a sentence there, the length is still the same.
Yes, data will remain. That if we make any single changes in data, for example, here I am writing RB. Okay, so
Okay,
RB
okay.
is D797. If I write RB dot, is changed.
Uh,
RB is like that, like Arion. Okay, Arion
mhm.
80 AC. Okay, please remember 80
Okay.
AC. I put
Okay.
dot, is changed 641.
Uh,
If
I
I
see.
remove
Okay.
dot, 80 AC is coming like that.
I
You
see.
understand?
Yeah.
Let us go more in depth.
Yeah, sure.
Now, what is block? Okay, block is the, is something where we are storing all of our transaction, right? Including, okay, what is our transaction? We are having, uh, perhaps, what happened. Uh, right now it's very difficult for you guys as a non-technical person to understand about the block, but but understanding block in a blockchain is to think about sheets of paper. For example, last time we understand, uh, if everyone have a sheet of paper, okay, in one big hall, and there will be one announcement is going to made, an announcement in term of transaction. As soon as any announcement will made, everyone start writing this transaction on that piece of paper. So just assume that block is a kind of piece of paper where you start recording all your transactions. Okay, so now we are going to understand what is block exactly. For example, if I write, okay, I am working with Albania leasing. This is my record. Okay, I record my I record my transaction in the block. Okay, let me correct this again, please. Okay, so this is,
Mhm.
you see, now block is invalid. How I know this is invalid? Because this shows as a red. I have to mine it. Okay,
Mhm.
so because system, I have putting my data, system is giving my hash, but there is none is missing, means I have to mine it. Miner has to mine it. Okay, how we mine it? We mine this data. You see, now it's become green. Give system is giving me new nonce number. This is the my computational power. My according to my computational power, system is giving me this number. Okay, means this is the combination between nonce, data, and hash. If I make any changes anywhere, for example, I put dot, it become invalid. If I remove
Ah,
dot, it's valid. You get my point?
Mhm.
yes.
So
Yes, sir.
Yes.
if even if I make any single change, for example, I said, okay, this is 44924 is my computational record. I said it should be 5. It's invalid. Means
Okay.
everyone will see this is the invalid block. Okay. But if I will revert it back as a 4, it is valid block. You get my point? Okay.
Yes.
For example, if I write some more data on it, this is Albania leasing, and there are 10 members in team. Okay, so this is my complete data. I have to mine it. So system is giving me new nonce. You see,
Mhm.
new nonce is 20099 according
Mhm.
to this data and according to this hash. Okay, so I will give you this one for your trial, and you can do your own trial according to this thing. Okay, uh, now let us learn what is the blockchain exactly. Okay, we have learned a lot of our about our blockchain. Let us learn what is blockchain according to different school of thought actually.
Hi, I'm Dr. Amy Killen. I have my own medical practice, and I've been using Doodly now for a few.
Okay.
Blockchains are incredibly popular nowadays. But what is a blockchain? How do they work? What problems do they solve? and how can they be used? Like the name indicates, a blockchain is a chain of blocks that contains information. This technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents so that it's not possible to backdate them or to tamper with them, almost like a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. Now, a blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside a blockchain, it becomes very difficult to change it. So how does that work? Well, let's take a closer look at a block. Each block contains some data, the hash of the block, and the hash of the previous block. The data that is stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about a transaction rule, such as the sender, receiver, and the amount of points. A block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its contents, and it's always unique, just as a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change. So in other words, hashes are very useful when you want to detect changes to the block. If the fingerprint of a block changes, it no longer is the same block. The third element inside each block is the hash of the previous block. And this effectively creates a chain of blocks, and it's this technique that makes a blockchain so secure. Let's take an example. Here we have a chain of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2, and number 2 points to number 1. Now the first block is a bit special. It cannot point to previous blocks because, well, it's the first one. We call this block the Genesis block. Now let's say that you tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks invalid because they no longer store a valid hash of the previous block. So changing a single block will make all following blocks invalid. But using hashes is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. You could effectively tamper with a block and recalculate all the hashes of other blocks to make your blockchain valid again. So to mitigate this, blockchains have something that is called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism makes it very hard to tamper with the blocks because if you tamper with one block, you'll need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there is one more way that blockchains secure themselves, and that is by being distributed. Instead of using a central entity to manage the chain, blockchains use a peer-to-peer network and everyone is allowed to join. When someone joins this network, he gets a full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, each node adds this block to their own blockchain. All the nodes in this network create consensus. They agree about what blocks are valid and which aren't. Blocks that are tampered with will be rejected by other nodes in the network. So to successfully tamper with a blockchain, you'll need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. So this is almost impossible to do. Blockchains are also constantly evolving. One of the most recent developments is the creation of smart contracts. These contracts are simple programs that are stored on the blockchain, It can be used to automatically exchange coins based on certain conditions. More on smart contracts in a later video. The creation of blockchain technology piqued a lot of people's interest. Soon others realized that this technology could be used for other things, like storing medical records, creating a digital notary, or even collecting taxes. So now you know what a blockchain is, how it works on a basic level, and what problems it solves. Want to learn how you can implement a simple blockchain in JavaScript? Then check out this video here. And as always, thank you very much for watching.
So you guys understand what is that now?
Yeah, interesting.
Yes. So that's how this block is created, and like I just wish to explain you some more thing on this part. Okay. So he discussed about the consensus. Okay. So we
Yes.
already, we already explore, what is the consensus algorithm, and uh, actually when we are doing some mining, so there should be consensus among the blockchain. For example, me and you done the mining in the blockchain network, and we said, okay, this record is validated, and we are ready to add this transaction into the block, right?
Yes.
Okay, but maybe there will be I have some wrong intention. Maybe I'm trying to create some malicious activities within the blockchain network. Okay, and I, so I and I have created this record intentionally, and make some malicious activity within the group. So but we have to make some consensus within the group whether this transaction is correctly recorded, there is no any malicious activity or something like that. So that's why we need to do some consensus algorithm. Let us learn in detail what is the consensus algorithm exactly. Okay, through this video. Another one.
يستخدم ستيف وديف منصة إيتورو للاستثمار في الأسواق المالية. يبحث ستيف.
There is one concept which is very famous in the blockchain world, consensus. So what is consensus? We'll talk about that in this video. Welcome back, aliens. My name is Arun Reddy, and let's get started. We know that blockchain is a distributed ledger. So let's say we have 5 mining nodes here. Now, all these nodes will be having a copy of a blockchain, and all the copy will be of same speed. So they are the exact copies here. Now, what if you got a new block? So yeah, we have done some transactions and you got a new block here. Now, this block is supposed to be added in a blockchain. But then which mining node will do it? Of course, if you say, hey, let's give it to the latest mining node, let's say mining node 5, and node 5 will add that in its own blockchain, and with the help of the protocol, we can just replicate in all the blockchains here, in different nodes. But there's a problem here. What if node 5 is malicious? So how you make sure that all the nodes come to the consensus and they will have the same copy of it? And that's where we have to follow some consensus algorithm. Now, in the blockchain world, we have so many consensus algorithms. So using which you can actually agree on one particular state of a blockchain. So if the new block is added in a blockchain, who will add it? That can be defined with the help of consensus. Now, based on it is permissionless or permissioned blockchain, we have different consensus algorithm available. The first one, which is proof of work, which is very famous thanks to Bitcoin. So Bitcoin uses POW to achieve the consensus. Right now, what is POW in short? Let's say we have all the nodes here. Now, all these nodes will spend some computing power doing some calculation, and whoever wins the calculation or whoever wins the puzzle, they will add this block in a blockchain. Yes, they will receive some Bitcoins, and that's a different concept, right? But in POW, we have to make sure that the node, before adding the data in a blockchain, is doing some computation. And that's how we can understand, yes, they have spent some computing power, so we can trust them. That's the POW part. We have some more. In fact, we have POS in the Ethereum world. Now, POS stands for proof of stake. But why we need POS when you have POW there? There's one issue with POW. We have to spend huge amount of computing power. Don't you think we are already short of resources available, and you're spending huge amount of resources, the power resources on the blockchain? So in proof of stake, we don't actually do a lot of computation. It's more about stake. So let's say if you are a miner and if you want to add that block in a blockchain, of course, in a Bitcoin network or in a Ethereum network, you will receive some Bitcoins or some currency when you win it, right? But then before applying for that or before going into that blockchain, you will be putting some stake in that blockchain. Now, when you say you have a stake in that, let's say I'm spending, let's say, 5 cryptocurrency of some type, maybe Bitcoins or some other coins. So I'm saying I'll be investing 5 coins there. But you might be thinking, okay, what's a big issue? Anyone can invest. No, if I'm malicious, I will not do that, right? Because if I'm malicious, if I do something wrong, they will kick me out of the blockchain, right? So I'm unsecure now. So when I say I'm spending 5 Bitcoins or 5 coins, that means you can trust me. So whoever has the highest stake, they will win the puzzle or they will win the blockchain. Likewise, we have so many other algorithms as well. We have POET, which is proof of elapsed time, built by Intel. Then we have POD, which is proof of deposit. So it's almost same as stake, but here you are depositing amount before entering to the blockchain. Then we also have POC, not the proof of concept, but proof of capacity. Now here you're not actually going for the computing power, which is CPU, which consumes a lot of electricity power, but here you are consuming the hard drive space. So whoever has the huge capacity, they might win the block there. So that's the general concept of consensus. So the idea is using consensus algorithm, we can actually agree on one particular state of a blockchain in the entire network. But we'll talk about this more.
So you understand about the consensus algorithm in detail, in depth. Okay. Yeah.
This was a little bit more technical.
Actually, it's not technical exactly. See, the consensus is something, we have to agree upon on something.
Okay? Yeah, sure. It's a common algorithm of
it's a common algorithm. Okay,
of
for
all
example,
nodes.
Yes. For example, if we are 10 people in blockchain network, and out of 10, if there 5 of them are agree on something, okay, so everyone should be, agree. If for example, like let's take an example of investigation. Okay. If you are, for example, I must say, what is the technical word for that? Hold on, let me. Okay, you are a dictator, detective agencies. Okay. And we have given you one task. Okay. There was one theft came, and he done some robbery in any bank. Okay, because you was not there in the location. So what you do, you will ask people who was there physically, right? You will get interview for example, 10 people, 6 people, and 8 people, something like that. And out of 10 people, 8 people will tell you same story, and 2 people will tell you different story. Who you believe? Out of 10, right? Out of 10, 8 people, right?
Yes,
the people, yeah. So the same thing adopt in consensus algorithm in blockchain. More people will tell the same story, you will consider them as truth. You agree? So the same mechanism is applicable in our blockchain consensus algorithm. So everyone, whoever will say the same story, so you will record the same thing like that. Okay. Now let us check another demo of the blockchain demo. So the same thing I already explained you in how you are creating hashes and how you creating the blocks. So there will be more in depth how we are having this kind of things through this video.
Be honest. Do you really want to watch a video that looks like this?
There's a good reason why presenters who
This is a blockchain demo. We're going to do this in a very visual way, though. I'm going to make it very easy to understand by stepping through the key pieces of what a blockchain is in a visual way. But before we get started, we need to take a look at this thing that we call a SHA-256 hash. Okay, and a hash, this is one of them right here. A hash looks like a bunch of random numbers. And essentially what it is, it's a fingerprint of some digital data. And it just so happens it's the fingerprint of whatever I type in this box. So if I type my name, Anders, into this box, you see that the hash has changed. As a matter of fact, it changed every time I typed a letter, right? So I'm going to go back to, so it says Anders. Okay, so this is the hash of the name Anders, all lowercase. It starts with 19EA, right? Okay, so if I delete that and I go again, type Anders again, you can see it starts with 19EA, the same exact hash. In that sense, it's a digital fingerprint of this data. Whatever data is here, every time you type exactly the same data, you get exactly the same hash. And I can type anything I want. So you can have nothing, like this, you know, E3B0, that's the hash of nothing. Or you could type tons and tons of stuff. As a matter of fact, you could put like the Library of Congress in here and you would get a hash. And the interesting thing about it is, regardless of if there's a tiny amount of information, no information, or the entire Library of Congress, you're always going to get a hash that is this long, this many characters. You're not going to be able to pre-guess what this is. You kind of have to put the Library of Congress in here to figure out what the hash is, but you'll always get exactly the same hash regardless of how many times you put exactly the same information in. So what I'm going to do is extend this idea of a hash into something that we're going to call a block. All right, so let's take a look at a block. So this is a block, and it's exactly like the hash. It's just that data section I've broken out now into 3 sections. One called block. This is just some kind of a number. This is block number 1. A nonce, which is just yet another number. We'll go into what that is in a second. And then just some more data, just very similarly to the way that we had it before. However, the hash of this, which includes all of this information up here, is down here, and it begins with 4 zeros. You see that? Yeah, that's a relatively unusual hash. You know, most of them are not really going to start with 4 zeros like that, but this one happens to. And because it does, totally arbitrarily, I'm going to say that this block is signed. Okay? So what would happen if I were to change any one piece of this information? Let's say if I were to type something here, right? The hash is going to change. And what's the chance of, if I type letters, this hash is going to start with 4 zeros? Pretty low. It's probably not, right? So let's see what happens when I do that. I'm just going to say 5. Oh, look at that, right? This hash does not start with 4 zeros. And so the big background here is turned red. So now you know that this block with this information in it is not a valid or a signed block, okay? And that's where this nonce comes in. This nonce is just a number that you can set to try to find a number that fits so that this hash starts with 4 zeros again. All right, so how do we do that? Well, let's start with 1. Does that start with, no, it's 3, 2, 7, that's not 1. So let's try 2, FF now, 3, 4, 5, 6. You get the idea. Like I could sit here, there's one that starts with a 0. I could sit here all day typing these numbers and trying to figure out one that actually is going to hash out to something that starts with 4 zeros. Going to take a long time. So here I have my little mine button. I'm sure you've been wondering what happens if I press that. So what's going to happen when I press this mine button is it's going to run through all the numbers from 1 all the way up to try to find one where the hash starts with 4 zeros. And this process is called mining. Let's do it right now. Now it's checking all of the numbers from 1 all the way up. Whoop, there, now it's stopped at 59,396. And that one just happens to hash out to something that starts with 4 zeros. And it satisfies my little definition of what a signed block is. Okay, so that's a block. Now, can you tell me what a blockchain is? It's probably just a chain of these blocks. Well, how do you put them together? Let's do that. All right, so here's my blockchain. I've block number one. It has some kind of amounts just like before. There's some data area to it, but then it has this previous. And here it's a bunch of zeros. Let's roll forward. So this is block 2 and block 3 and 4. This blockchain has 5 blocks on it, right? The previous here starts with 00 AE8, right? Is this number, AE8. And then this previous, B90 is this one over here, B90. So you can see that each block points backwards to the one before it. And you remember that first block over here, there actually is no previous, so it's just a bunch of zeros. It's actually just a fake number. Okay, so just like we did before, what happens if I change some information here? Right, it's going to change the hash of this block and it's going to invalidate it, right? Well, let's try that. So I'm going to type I again. Sure enough, that block is invalid. All right, just as we assumed. But what would happen? I'm going to fix that now. We'll go back to something that worked. What would happen if I change something in this block? Right, it's going to change this hash, but this hash gets copied up to this previous. So it's gonna change this one too, right? So it should break both blocks. So let me try typing hi in there, and sure enough, all right? So we can go back as far as we want, to some point in the past and break that block, and it'll break all the blocks since then. Everything before is still green, but this one is red. So if I wanted to, change something in this blockchain, I could just go over to block number 5 right here. We could change it. I'll put I, and then we could remine it, and pick a different nonce. We'll do that right now, and we could essentially alter the chain. So we've done it. So that we should be good now, right? All right. Well, what happens if I go back in time to here and I break it here? Now I have to mine this block, which will pick a nonce that makes this block hash out to 4 zeros, if we can find one. Sometimes it takes a while because it's got to run through a lot of them. There it is. It found one at 138,000. All right, but this one is still broken because although this one starts with 4 zeros, adding the 4 zeros with different stuff up here still makes this block hash out incorrectly. So I also have to mine this block. All right. And that takes some amount of time. That one was a little bit quicker. And then I have to mine this block to fix it. All right. So what we're showing here is that if I go and change this last block, all I have to do is remine this block. If I go way back in time to back here and I make a change like that, I'm going to have to mine this one, this one, this one, and this one. So the more blocks that go by, the more blocks in the past that we are, the harder and harder and harder it is to make a change. And so that's how a blockchain is going to resist mutation, resist change. Okay, so now, like I did, if I do this in this block here, you can see that I've changed it to high and I remined it, blah blah blah. How would I know that my blockchain has been remined? All right, let's take a look at that. I'm going to hit this little strip.
So you guys understand what how blocks are created and how it get mines, how blockchain is created, and how it's difficult to broken any chain, because this block is get created almost at every 10 minutes. Okay, so how it's difficult to make any kind of corruption in the blockchain actually. So
So It is possible, not impossible.
It is possible, but you need, extra high power of energy, high power of computational power. You need cord of computers, So for example, one block is recording so many things together. First of all, previous hash, the data, the transaction record, time stamp, So for example, it's time stamp in term of what time is if the transaction was recorded. It was 2:20 p.m. and the second was this. So you have to change each and everything, each and every transaction. Do you think can you do that? It's impossible. It's next to impossible actually.
Okay.
So it's you need high power of computational power. This you need cord computer, something like that. So break to in order to break any kind of any blockchain ledger actually. Okay. So that's all from my side. Today we have learned a lot, and we have seen this demo over there, and the same thing we have uh, we learned how blockchain are created and how it goes together actually. Okay, so
Thank you, brother.
if there is any queries, any question from your side, please let me know. Otherwise we are ending up our today's session, and inshallah to next class we will going to learn other few things actually. And I believe in next two classes we will finish our basic concept of this blockchain. And if you wanted to learn other thing, other stuff, I'm ready to teach you. But you can
Thank you.
check internally how we can move forward. Okay, brother?
Okay, thank you,
Okay,
brother.
thank you. Inshallah. See you next week.
Thank you,
Bye.
brother.
Bye.
Goodbye.
Bye bye.